Now, we would like to move on to the next part of the speeches. The next speaker here is Mr. Yamaji Hiroyuki. In the confidential computing environment, the language processing is now run. So he is making large contribution in various facets. Today, he will focus on the Ruby interpreter, which is run by the Intel SGX enclave. Now the stage is ready. Mr. Yamaji, could you please start your presentation? Thank you. I'm sorry, I apologize that it took some time for the preparation. Ruby interpreter, which is run in the Intel SGX enclave. My name is Yamaji. I am from Tsukuba University. Intel SGX enclave, what is it? I would like to explain what it is. In recent times, while collecting data program is to be run, and there is such an increasing demand. For example, Microsoft Azure and Google Cloud are the cloud services. Users actually do not trust that providers, but they can actually execute the confidential computing system. And in the personal environment, a server is actually doing that confidential calculation, and the copyright is done, and while data is acquiring and obtaining that service is provided. So because there is a processor help, and the isolated program can be run. It is called the confidential computation or computing environment. The environment is actually depending on the integrity of the data, and so confidentiality of the data, and also the integrity of the data. Outside this environment, a software program might be run. Therefore, those programs cannot access the internal data or modify that. In this environment, there are various multiple representative implementation trust zone. At the time of the booting, secure world, which is actually the environment, and can be generated and created. In normal environment, the process is run. Secure world and is actually executing that the confidential processing. AMD is actually providing secure encrypted virtual SAV. The total BD is actually encrypted, and then confidentiality is protected. Intel processor provides software guard extension SGX inside one process, and a specific function can be actually implemented in the confidential environment. SGX is compared with SGA, and the programs run in that confidential environment can be actually made smaller inside. Therefore, that vulnerability cause risk is minimized. That is the biggest benefit we can gain. Intel SGX was chosen in my research for executing this concept. SGX provides that confidential environment. From the sixth generation Intel Corpus processor incorporates that on the memory enclave, and is a protected area, which is actually on that surface, and the number can be done, and the OS hypervisor can be actually included. They are all isolated from other users. SGX features are quite prominent, and protection is by the level of function. Enclave and actually the normal environment and have got a order, and actually function call is actually one possibility, and from the outside to outside and inside it is an equal, from inside to outside or call. In this particular case, this is a normal func1. By u equal the func2 inside enclave can be called. The enclave and func2 can be actually called and is calling func3 in the normal environment. SGX has got a certain problem, so there is a limitation that it cannot actually execute. If an encode is used for the system call or call is used, so you have to go that it has to go outside first, and then in the outside coding can be performed. SGX and program and development C language and C++ and Rust and so Go are oriented, and the kits are available. In these kits, enclave system call is not actually accommodated. Therefore, there is a limited function in the standard libraries. Those languages, the compiler type of languages, the script oriented development kit is not made available yet. In this environment, the Ruby-oriented SGX program is to be developed. That is a very strong demand. Ruby-based development can be made possible. In that case, garbage collection and high-level processing possible. When compared with C language and C++, the destruction risk of the memory is minimized. Ruby-based development is possible. What are the methods? Inside the Ruby, interpreter can be executed. That is one solution. In the enclave, interpreter is now to be executed, but the system calls cannot be used. That is SGX limitation, which is a big barrier. So the script shield, which is available, was modifying the libc, and the all-code based and the transparent was possible. C language based was possible by enclave. So Lua and JavaScript and also Square interpreters can be executable in enclave. Having said so, however, system call implementation is not sufficient. Ruby uses that implementation in other complicated interpreter. This is not still accommodating their demand. There are other options where assembly and WASM can be implemented or can be utilized. In Ruby, interpreter itself can actually compile to WASM, and if WASM runtime can be actually combined together with that, and in enclave, a Ruby execution will be made possible. Having said so, however, I tried this particular method. WASM runtime implementation was not sufficient. Therefore, inside enclave the interpreter could not be actually executed. Even if it is possible, WAFNA does not provide thread and also nest, and the interpreter cannot actually accommodate and respond to those functions. In this environment, therefore, C Ruby run in that enclave is in SGX enclave. By achieving that Ruby based on the high-level processing is possible, and also risk will be minimized for the memory loss. So this is the policy. Ruby interpreter has got a new environment. SGX should be defined first. In this environment, this is different. This offers a different API, which is not the same as a standard library. API is essential for the interpreter. All of them are used, and the Ruby application uses certain ones. They are also provided. Enclave development kit does not offer certain APIs, then the unique implementation is done. By using OCall, that outside an API can be used. Outside an enclave, API is used, and then the values cannot be trustworthy in total. That could happen, but the Ruby application developer should be actually understanding that and should make their own decision. Outside enclave API can be used. The semantics might be modified according to that. In that case, we do not plan to offer that sort of a function. This is a policy. Ruby interpreter is compatible with WASM. There are some modifications to make it compatible. So that can be used as the reference, and when the Ruby interpreter is run in the in WASM, and they are quite similar to each other. The environment are very similar. In the environment of WASM, Ruby is implemented, and in addition to the Ruby interpreter, WASM-VC is used as a standard library. And WASM-VC is a MuscleDBC implementation. So that is a very basic implementation. The API offered by that and is a subset of MuscleDBC. In the enclave SDK offering a standard library is called OEDBC, and like WASDBC, MuscleDBC is based for the implementation. Therefore, that offering function is very similar. Due to those reasons, for these reasons, interpretation, the transplantation should be oriented to is actually taking the reference to the Ruby implementation towards WASM. This is a Linux-oriented Ruby interpreter. The system call is used, and actually it is actually compatible inside. Having said so, however, semantics might be modified in some cases. In that case, you cannot actually respond to that by using OCode. For configure script should be modified in the first place. What is configure script? Interpreter is built up at the time of that, and depending on the build environment, and the script is used for making that. In the configure script, a new build environment is actually added as SGM. In enclave, the library and compiler option as necessary. They are designated by that. In the implementation of configure, enclave and disable. So some functions which are not can be used and can be disabled. Garbage collection and stack. Let me discuss this one. The implementation of Ruby is based on the stack and the register, and then the referred and the obstacle is processed. The stack processing requires a certain start address, and in Linux, that start address is an pthread attribute and get stack. That is a function in the standard library. However, enclave and usable PC is get stack and is not actually offered by that. Outside enclave API is to be called by on-call. Semantics is modified. Therefore, the on-call based implementation is just impossible. In SGX, enclave uses the max stack size, and enclave can actually bring in the maximum number of threads, and actually at the time of enclave, the setting that is statically set. In the newly developed development kit as shown, the total stack region of that enclave can be divided by the number of threads. And then each region is actually defined as each respective thread stack. For these reasons, the insufficient thread attributes are actually identified. The development kit is offering OEXDTD to CS API. So by using those APIs, the start address is actually can be obtained, then the implementation can be performed. By taking those methods, the garbage collection of the stock can be correctly done. The thread API, there are certain problems we have to address in the thread API. The Linux-oriented Ruby and the pthread is used for the thread API implementation. However, enclave-oriented and pthread in API thread function is not offered. Furthermore, mutex and also conditional variable are actually the unique implementation in, and therefore the pthread outside the enclave cannot be actually used as they are. Then the thread generation function inside an enclave, so 1 versus 1 generation is actually taken as a policy. Inside the enclave, the thread creation is called pthread create, and then by all call from outside helper 1 is called. Helper 1 outside enclave is actually subjected to the normal environment, and then by using the pthread, and it performs its function. And inside the enclave, and helper 3 is executed. Helper 3 is originally what can call that function F. O-call was used for the calling of helper 1. After the thread set up, by O-call can return to inside an enclave. And so the thread outside and the function F, and inside the enclave there are three threads in the enclave. So the two threads can be called inside an enclave. By having those implementation, the Ruby implementation was made possible. The simple calculation and garbage collection can be performed, as well as a piece thread and thread API use and file I/O inside the enclave. Those can be performed. What are the remaining issues we have to address? By encryption, file I/O, and also enclave code and integrity can be actually verified by the remote attestation. So we can actually achieve that. We plan to achieve that remote station. So in normal environment, an interpreter is working, so the coordinated function is one of the agenda we would like to address. This is a summary. SGX and enclave, and inside the enclave, and C Ruby is to be run. A new builder environment was set, and also thread and stack address should be actually implemented, and also the thread and collection was actually done. By using garbage collection, and the enclave was enabling those Ruby interpreter. Thank you very much for your attention. Thank you. Dr. Yamaji, thank you very much for your presentation. Due to the time limitation, we will not have the time to entertain questions from the audience. If there is any question, could you please meet the lecturer and speakers in the later times when you exchanging names. Now, could you please give him the round of applause to express our thanks to Dr. Yamaji. Thank you.
Now, I would like to invite Mr. Tetsuya Hirota of Dogland Corporation. Could you please wait a while until the stage is ready? Thank you.